Right, I'm going to explain the process of implicit differentiation. Implicit differentiation, by definition, I can write it down here. It makes use of chain rule to differentiate a function, to differentiate functions which cannot be explicitly expressed, in the form y is equal to f of x. So we've got those functions that are so difficult to express them in the form that were used to where y is the dependent variable and x is the independent variable. So we will use the technique of chain rule to differentiate such type of functions. For example, imagine you've got y cubed plus y is equal to x. So trying to make y solve with formula here is already a problem because of the y to the power of 3. So what we know is, if we've got a function, if y is equal to f of y of x, such as that function here, we can differentiate it by saying d over d of x, yeah, f of y of x. So we're going to use the chain rule in here, which is basically df over what? Over dy times dy over dx. So that's the function. That's the rule. That's the rule. That's the chain rule. Yeah. This can be summarized by the notes that are here. This is basically the rule. So in most cases, you're not asked to prove that. You're just asked to use it. So this is the rule. This is the rule, which I just said. This is the same as just saying d of what? Of f of y of x in here. Let me close the bracket. It's the same as saying df over dy times dy, the inside function with respect to dx. That's the chain rule. That's the chain rule. So we are going to use this rule to differentiate implicitly, and all the other techniques that you've done as well, including the product rule. So let us look at the examples that come with this type of differentiation technique. Number one, find the derivative. X to the power of 3 plus x plus y to the power of 3 plus 3y is equal to dx. So we're just going to differentiate the whole statement. We know that since x is the independent variable, so the derivative of this is 3x squared plus 1 plus 3y squared. But because this is the dependent variable, we apply the chain rule here. So that's dy over dx plus 3, again the chain rule here is dy over dx. is equal to 0. So since we want dy over dx, we are going to factorize dy over dx, and we are left with 3y squared plus 3y, and these two terms here will be 3x squared plus 1. So dy over dx is equal to minus 3x squared plus 1, and then 3y squared plus 3. That's how we do the implicit differentiation. Next example, you might also see that this is a product, this is a quotient, so you've got two ways to deal with this one. I would advise maybe for this one it is much easier to rewrite it and say this is 6x squared y to the power of minus 1 is equal to 0. I'm going to use the product rule. So the product rule is, if I take away the 4 and apply the product rule on x and y squared, I'm going to have x, then in bracket 2y dy over dx, that's there, chain rule, plus y squared, the derivative of x is just 1, close the bracket, plus x squared, the derivative of y to the power of minus 1 is going to be minus y minus 2 dy over dx plus y to the power of minus 1, the derivative of x squared is 2x. The derivative of, okay, it's just 0, so it's just minus 0. So now we want, so with this, there's no really a good reason for you to arrange everything, because we already know this is the derivative, this whole statement. But because we are given substitution, numbers that we need to substitute, we can just place them in here. X is 1, y is 1, that's 2 dy over dx plus 1 squared plus 6, that's 1 here, you can put 1 squared minus 1 to the power of minus 2 plus dy over dx. That's just going to be 1 minus 1 times 2 is equal to 0. So we want dy over dx so that gives us 8 dy over dx. This 4 is multiplying everything here plus another 4 here. This side here, just having a look at it, then the negative here is still going to remain, so we're going to have the minus, so I'll need minus here. So we're going to have minus 6 dy over dx. This 6 goes there, it does affect, but there's a trick here. Careful with such kind of expressions. So it's plus 12 is equal to 0. Right. So now it's just a matter of simplifying it again. 8 minus 6 is just 2 dy over dx. 4 plus 12 is just 16 is equal to 0. So we're going to have dy over dx. Actually, we got minus 1. So that's a good thing about substitution. You don't really need to do a lot of arrangements to get the question into an arranged form. You can just, once we've differentiated, you can just substitute straight away. Next question, again, it's the same thing of substitution. But what's important to remember is the techniques of differentiating natural log and e. So this is a product here. That means I'm going to say e to the power of 2x and differentiate natural log of y, which is 1 over y and dy by the chain rule over dx plus natural log of 1, and this is just 2 into x is equal to 1 plus dy over dx. Then the derivative of minus 2 is just 1. It's just 0. If we substitute these numbers, we are going to have e to the power of 2 dy over dx with 1 over 1. Usually you might just keep that, plus natural log of 1, which we know is going to be 0, 2 to the power of 2x, 1 plus dy over dx. Alright, what it means now, we're left with e squared dy over dx. This whole part here becomes 0 because natural log of 1 is 0. And this is equal to 1 plus dy over dx. So this further implies you are going to have e squared dy over dx minus dy over dx is equal to 1. Simplifying a bit further, so this gives us dy over dx. E squared minus 1 is equal to 1, which further tells us that dy over dx is equal to 1 over e squared minus 1 is an exact value. That's our answer. Next question. Can you find the gradient of the curve with the equation natural log of y squared is equal to half of x, natural log of x minus 1, at the point where x is equal to 4. So we need the value of y when x is equal to 4. So dealing with this might be advantageous to just make y the subject of the formula by having e half of x, natural log of x minus 1. That's just basic log rules. That tells us that y squared, if x is 4, I'm going to have e to the power of 2 natural log of 3, which is just e to the power of natural log of 9, which is just equal to 9. So y is equal to plus or minus 3, but we are interested if y is equal to 3, since y is greater than 0. So the coordinates we are talking about here is x is 4 and y is 3. Now we proceed with simplifying this function. We need the derivative. So the derivative of this function is to differentiate across. So remember, y natural log of y is written as 2 natural log of y, which is equal to half x natural log of x minus 1. So you are going to have 2 1 over y dy over dx is equal to, I'll put big bracket here so that I can do the product rule. So this is going to be equal to x in bracket 1 over x minus 1 plus natural log of x minus 1 in bracket. The derivative of x is just 1. So when x is 4, y is 3, so I'm going to have 2 over 3 dy over dx is equal to half x is 4. So if I put a 4 here, I'm going to have 4 over 3 plus natural log of 3. So that means dy over dx. That means dy, let me just multiply everything by 3 over 2. I multiply everything by 3 over 2. This is going to be 3 in bracket 4 over 3 plus natural log of 3, which perfectly comes up as 4 plus 3 natural log of 3. Right? So that is how we use implicit differentiation. Thank you.